Hello, my fellow YouTubers. This is Roy back again. You got to be asking yourself, what does that have to do with this? Well, when I started creating this mechanical version, I started to think how I can create one that's in a coil form. Dual primaries. All right. Let's start off real quick. I'll go through this and you guys can be on your way. So we'll start off with A, B, and C. A is the primary. The top one here it's a bifilar, and you can see that the start of the primary is right there. So it turns counterclockwise, and so does the coil in the center. Turns the same way as this coil. It's the primary. Now, underneath the primary and sandwiched in between these two conductors is a dielectric, and here we have a pickup. And this pickup is wound clockwise. So it starts right there, and it's wound the opposite way as the top section and the opposite way as that coil there. And this clockwise is the wind that's on this coil down bottom. Now the interesting thing with this is I'm going to set the primary up to start off with my 15,000 volt 60 milliamp beer bottle capacitance, and we're going to fire up this primary and treat it like a agitation cycle on the washing machine. So it'll be swapping where that start connection is positive on a half cycle and negative on the other half cycle. And we'll have a contact out here when we find the resonance. When we start to tune this thing, we'll find resonance in one of these turns out here. You can see there's 1, 2, 3, 4, 5, 6, 7, 8 turns. This here is our pickup coil, and that will release the capacitors that will be discharged. And something unique I just figured out, let me see if I can get this on the ground, one hand, is the inside. See if I could get a good view. So the cone of the coil down bottom protrudes into this coil, and vice versa, this coil protrudes into that coil, about that much into the coil. So I can't say a third, but a good portion, a good eighth. You can see that the rod here is the elevation, so I would almost say it is a third to that rod. There's a rod on both sides. The crazy little phenomenon that I realized already is I was trying to dry out some of the polyurethane that I have on here, and I stuck a fan on it, and when I did, this is what I noticed. Now I want you to, this fan's on high, okay? Now watch what happens when I stick the fan. Listen to the fan. The fan slowed down. The fan slowed down. Let's pick it up. You can hear it's so high, moving fast. I lower it down on this. it slowed down. Kind of reminds me of the conductor, the aluminum conductor I put around the magnets, where the wheel slowed down to nothing. It didn't. It's not stopping this, but it slowed it down. And here, pick up speed right there. So that's an interesting thing, but it kind of stands to reason why it would happen, because of the magnetic field in that fan motor is being choked down by the conductor of copper. The same lens effect just showed up. Mr. Lens just showed up in our face, and that's the unique thing about this. So what am I expecting to happen when I go to hit this? I'm not trying to make a Tesla coil, but this is a unique array, and I would say it's leaning towards the free energy device and how it would create free energy. It would tap into the ethereal energy on the backswing, just like a transformer power lines do when they're in between their cycles. They trap in ambient radical electrons in rarefied air, and that's what we're looking here, because this cone being wound clockwise, so there's a clock rotation. This cone comes up and clockwise up to about this high here, or about this high, and then you got that rod with the wire coming up, and that wire needs to go to something, and I believe that wire is going to go into a capacitance. Now, whether or not I use a toroid and use the toroid, but that to me seems a little Tesla-ish. If I had one on the top and one on the bottom, but there's a multiple experiments I need to do here, and I'm not looking for energy to blow out like the Tesla. So it would be, I would think it'd be more on capacitors that are like, let me see what I have in the goodie box back here. It's got some weight. So maybe something like this. I call these little cherry, they're capacitors that are 20,000 kV. Let me see. It's upside down. Should be 21,000 kV, and that's 1,500. Be nice if I can focus in there. 1.5 nanofarads of capacitance. So I build 2 capacitor banks. Have that capacitance release. Now, what's going to happen on this equatorial plane, I'm going to call this, it would be, primary would be A, and then you would have pickup would be A plus, and then A prime, we'll call it, and then you would have B would be your pickup here, and then there's going to be about 300 turns of some 26 gauge wire that's going to be right here, and that's going to be the start of the secondary, which will be these coils here will be secondary coils, and that would be A prime, B, and then B is going to have B prime right there, and then there's going to be C, and C is B prime is the secondary pickup, and then that's C and then C prime will be the secondary itself. Now the secondary itself, it's taking the positive end and running through each other. So it's going to be the high side about right here, and then it'll be the high side from this cone about right here. So there's going to be a difference in potential will be spread out in the middle. So there's the potential difference between this bottom point and this top point will be because I put a resistor on one of these coils. They're both about one's 5.9 ohms, and the other one I have 6.9 ohms. So I got 1 ohm difference between the coils. So with both of them being hit at the same time, there's going to be a difference in potential between the top of this point and the bottom of this point. And we're going to call that a diamond, because you're going to have a top end of the diamond here and a bottom end of the diamond. And then you're going to have your dielectric, which is shooting out through the sides. Now we're going to break out with the oscilloscope. I got to put a couple more coats on here. I want this to be about a good 1/8 of an inch thick in poly. It's really insulated good. And we're going to do an experiment with the oscilloscope, and we're going to look at the wave. And we're going to focus on the wave that is being produced, which we're going to have to use my variac off the wall into the NST, and we're going to have to go down in volts to get it first 100 volts, then 200 volts, 300 volts, and start looking at the wave, and then go up in volts and see what characteristics change. And then from there we're going to focus on the wavefront. And when I say wavefront, is how much are we going to charge up the capacitor banks? There's going to be 2 banks, right? So the capacitor bank is 1, the current, 2, the wavefront. So if you look at a circle, it's 360 degrees. And obviously you have to have a reference point of where the circle starts. So if you look at the start of the wire, say on the primary here, that would really be the 12 o'clock position. So one end starts 1 o'clock and it goes around. That so that would start the position of the 360. So we would have a time frame from say from 0 all the way around to 360, whether it's 180 or whatever you use on there. In reference in time to get there, that's going to be the charging time of the contacts of the assembly circuit that would ultimately charge the capacitor and release the capacitor. And the capacitor released will look at the capacitors being like Eli the Iceman, where the current is leading the voltage coming out of the capacitor, and the wavefront, the angle of that wave is going to be what we're going to be matching on the angle of the cone. So this is like a 22.5 degree angle. Now once we match that capacitance wave front on the oscilloscope to the wavefront of the cone, we'll start to see some formulation of resonance built up in the humps of the sine wave that we're creating from the NST. A lot more to get into, guys. I sort of get myself a little lost without without just not having it written down, which I will do. And I just want to say the fact that to build something mechanical from a vision and to understand these magnets are more like little coils, and these coils you charge up and they become strong magnets, and you can't look at them as just magnets, or you can get caught up in getting lost in what is it really going to do. This array here will bounce into and will work off the electrostatics in the center, and we'll talk about referencing how what I'm building here in a rough mock-up to what I'm building here as a fine-tuned transformer that will create a space from the top of the cone and the aura on top of the cone to the bottom of the cone on this one to the aura of the cone is the electromagnetic field, is the aura I'm calling it, and then the expansion. So we'll be able to see the wavefront change on the oscilloscope as I expand the 22 degrees that we have here in a, we'll call this, in a computer sense, you have your software and your hardware. So this here is the hardware, and then the software, we're going to apply and tune it, and then we're going to vary the degrees. So the 22.5 degrees start can also be altered to go outward, just like it is on the one chart that I'll bring a couple charts out from Walter Russell, and this is just my version of what Walter Russell and James Clerk Maxwell, my ether friend, the spirits of himself, James Clerk Maxwell, and Walter Russell, and Benjamin Franklin, and Mr. Tesla. They keep showing up in my workshop and keep introducing themselves to me, and out of nowhere I'm into this. Leave your comments.